In this video I'm going to be walking you through the solutions to the packet. As you can see, the first three are done here. I started doing number 3 and I noticed that my marker ran out. So anyway, you can see -1, 3, and D and E would be the first three limits. Just a reminder that a limit is the intended value that the function is approaching, the intended value. So keep that in mind, the intended value. And sometimes the intended value and the actual value are the same thing. But nevertheless, as we see here, as x approaches 3 from the left, the function is a constant, and we don't really care what happens when we get to 3, but what we do care is that it's starting at -1, it stays at -1, that's why the limit is -1. Likewise, as x approaches 3 from the right, the intended value, the exact value is 3, which is also the intended value, and it stays there at 3, so that's why the limit is 3. Okay, so I'm just going to walk through here, and I guess I can answer your questions later, but this will help you see kind of the thought process here. F of 3 is 1. Limit as x approaches -infinity, -1, it doesn't change from that. Positive infinity, the limit is 3. Okay, for number 3, as we can see, we have a continuous function here, so there's no breaks in the function, so the intended value is the same as the actual value. So the limit as x approaches 4 from the left is 1, 4 from the right, also 1. When these two numbers match, then C, the limit as x approaches 4, is also 1. G of 4 is also 1. As x approaches -infinity, what it looks like is going on is that this function is continuing to go down toward -infinity, so we would say -infinity. And then as x approaches positive infinity, it looks like the function's values continue to get higher and higher, so we would say positive infinity for that limit as well. Now there could be a case made for D and E, but D and E doesn't necessarily give us as much information as these. -infinity here, knowing that the y values are getting smaller in the negative direction, or bigger in the negative direction, as x gets closer and closer, or farther and farther to the left. And then, as you can see, the limit being positive infinity here shows us that the y values are getting bigger in the positive direction as x is getting bigger in the positive direction. So that's why we would use positive and negative infinity for those limits instead of D and E. So for numbers 2 and 4, 2a, as x approaches 2 from the left, the y values are moving right up there toward 2. X approaches 2 from the right, y values are getting closer to 0. D and E. F of 2 we see to be 2. X approaches -infinity, it looks like y equals 0 is a horizontal asymptote, so the y values are getting closer and closer to 0. X approaches positive infinity, and the y values are getting closer and closer to 2. Okay. Number 4, x approaches 0 from the left, y values are getting closer to 3. Y values are getting closer to 3. X approaches 0 from the right. X approaches 0. These two numbers match, so the limit as x approaches 0. This means, again, from both sides. And then g of 0 is also 3. Okay. Now, normally in a classroom full of students, half the students think that this is kind of like a cosine graph, where it's going to keep going back and forth across the x-axis. And then the other half think that, just like I do, that the function is just going to keep going up, up, and away toward positive infinity. So if by chance you interpret it my way, you would just say infinity for both of these limits. If you think, though, that if you interpreted this as it going back and forth across the x-axis, then you would say D and E for the limit. Okay, so you're going to be right either way. This one's not clear, so don't worry about not getting infinity here, as long as you understand that if it goes back and forth across the x-axis, then the limit will be D and E. Alright, halfway done with the homework. So here we go. Number 5, x approaches -2 from the left, y value is getting closer to 0. -2 from the right, y value is closer to 0, so that makes c 0. F of negative 2 is 3, output is 3. X approaches negative infinity, y is approaching positive infinity, and same with when x approaches positive, y also approaches positive infinity. Okay, so this is a phi, that little Greek letter is a phi of x. Okay, it's not fong of x, it's phi of x. Anyway, x approaches negative 2 from the left, we can see that the y values are going down toward negative infinity. X approaches negative 2 from the right, y values are going to positive infinity. And then, so therefore, it can't get any farther away than negative and positive infinity, so we have d and e for the limit there. Phi of negative 2, there is no output, so that is also d and e. As x approaches negative infinity, we can see that we have a horizontal asymptote at y equals 2, so the y values are approaching 2. We also, it looks like this graph has a horizontal asymptote at y equals 0, so the x-axis. So therefore the y values, as x gets positive, more and more positive, the y values are approaching 0. So we have a limit of 0. Okay? And then 6 and 8. All right. Number 6, x approaches 3 from the left. Intended value is 2. 3 from the right, intended value is also 2, so the limit as x approaches 3 is 2. Okay. Remember, don't let your algebra eyes get in the way of your calculus eyes. We can't tell with our calculus eyes what happens when when x actually gets all the way to 3, but what we do see is that from either side of 3, of either side, the y values are right along this line. So we're going to pretend that we don't know there's an open circle right there where x is 3, and then a closed circle, well, a dot right there up there at y equals 3. So we're going to pretend we can't see that with our calculus eyes, and we're going to say, okay, limit is 2. However, f of 3, now we open our algebra eyes, and we know that when we put 3 in, we get a 3 out. Okay? As x approaches negative infinity, we can see that limit is negative infinity. As x approaches positive infinity, we get positive infinity there. Okay? Let's see here. Another phi of x. As x approaches 4 from the left, we get positive infinity. 4 from the right, also positive infinity. Now, some textbooks would say positive infinity here. Some textbooks would say d and e. You can do either one. Doesn't matter. As long as you know that from the right of 4, the y values are going towards positive infinity, and from the left of 4, also positive infinity. Okay? Phi of 4, you can see there's no dot on that vertical asymptote, so we would say d and e for sure. Okay? As x approaches negative infinity, now, as you see here, we have a horizontal asymptote, that dotted one right there at negative 1. But also, it looks like the x-axis is a horizontal asymptote. Okay, so that looks like it's just kind of coming in for a landing right there, so the y values are approaching 0. But that horizontal asymptote at y equals negative 1, it looks like the right side of the graph, the y values are approaching negative 1.